All right, so here we got a problem again trying to find the minimum sample size. I did a lot of explaining on the previous video with it. So a television sports commentator wants to estimate the proportion of Americans who follow professional football. What sample size should be attained if he wants within 3 percentage points with a 95% confidence interval? So my margin of error is 3%. So again, here's our standard formula here. Margin of error has got to be greater than or equal to the Z star times the square root of p hat times 1 minus p hat over n, and we got to solve for n. So margin of error is 0.03. It's got to be greater than or equal to a 95% confidence interval has a 1.96 Z star associated with it. We are basing this for p hat is based off of the previous study of 53%. So we got 0.53 times 0.47 over n, and then now I need to start solving for it. So eventually what's going to happen as we go through, I'm going to have 0.03 divided by 1.96. I got to square it, and that gives me the top of the fraction. So let's want to get the calculator now involved as I try to simplify some. 0.53 times 0.47 would be 2491.2491. And we're going to go ahead and trade places there and say that n is greater than or equal to 0.2491 divided by 0.03 over 1.96 squared. And that's what I'm going to type in the calculator to go a little bit quicker. Again, my other video on this goes a little bit slower through it in the process. So alpha x gives me a fraction, 0.2491 on the bottom. I'm going to give me another fraction, and I'm going to have it, I'm going to eventually square it, so I want to get parentheses around it. 0.03 on the bottom is 1.96. Go off to the side of the fraction and then square it. So that looks about right. And I get that n has got to be greater than 1063.27, so it's got to be bigger than 1064 is what we got to be bigger than. We always round up to the next whole number. They said, what if you don't have a prior estimate? Well, that means I have to use my p hat. In this case is going to be 50%. It's going to be 0.5. So with that in mind, what ends up happening is the only thing that changes is the top of the very top fraction. So my formula would be n is greater than or equal to 0.5 times 0.5 over that other stuff. And 1.96 quantity squared. So I'm going to go back on the calculator here, and I'm going to tell it to take the last formula that I did, and I'm going to arrow up and change that to be 0.5 times 0.5 is 0.25 is what that is. So I'm just going to change that to be 0.25 on top. Go ahead and hit enter, and I get 1067, or actually 1068. It's 1067.11. We would say 1068 is what we would say. Why are those so close? Well, it's because our p hat in the first case in part A, our p hat was 0.53, and in part B, our p hat was 0.50. So it should be a little bit bigger than the other one, but it's not going to be astronomically bigger just because we just went from 0.53 to 0.50. And same thing even if we look at the 1 minus p hat. The 1 minus p hat was 0.47, and this other one here was still 1 minus p hat was 0.5. So they're very close in values for what we put in there for the p hats, and so that's why those answers are very similar.